You can find the wrocks.com downloads for this chapter at www.rocks.com/go/python projects on the download code tab. The code is in the chapter 1 download and individually named according to the names throughout the chapter. This chapter starts with a brief review of Python in case you have forgotten some of the basics, and provides a foundation upon which the rest of the book is built. If you are confident in your ability with basic Python coding, feel free to skip ahead until you see content that might be of interest to you. After all, you can always come back to this chapter later if you find you need a refresher. In this chapter you start off by looking at the Python ecosystem, the data types, and the major control structures, and then move on to defining functions and classes. Next, you look at the Python module and package system. And finally, you create a basic new package of modules. By the end of this chapter, you should be ready to take the next step and start working with the standard Python modules on real project tasks. 1. 2. Chapter 1 Reviewing Core Python. Exploring the Python language and the interpreter. Python is a dynamic but strictly typed programming language. It is both interpreted and compiled in that the original source code is compiled into byte code and then interpreted, but this happens transparently to the user. You do not have to explicitly ask Python to compile your code. The Python language has several implementations, but the most common is the version written in C, often referred to as CPython. Other implementations include Jython, written in Java, and IronPython, written for the Microsoft.NET platform. CPython is the implementation used in this book. Note at the time of writing, there are 2 version streams of Python, versions 2.x and 3.x. This book focuses on version 3, and the code has been tested on several releases within that stream up to release 3.4. Where major compatibility issues arise with 2.x, reference will be made to version 2.7. Python programs are written in text files that customarily have the extension .py. The Python interpreter, called Python, in lowercase, does not actually care about the extension. It is only for the user's benefit, and in some operating systems to allow the file and interpreter to be linked. You can also input Python code directly to the interpreter. This method makes for a highly interactive development style, where ideas are prototyped or tested in the interpreter and then transferred into a code editor. The Python interpreter is a powerful learning tool when you are starting to use a new concept or code module. When working in this mode, you start the interpreter by typing Python at an operating system command prompt. The system will respond with a message telling you the Python version and some build details, followed by the interactive prompt at which you type code. It looks like this. Active Python 3.3.2.0, Active State Software Incorporated, based on Python 3.3.2, default, September 16, 2013, 23 hours 10 minutes and 6 seconds, MSC v.1632-bit, Intel, on Win32 type help, copyright, credits or license for more information. This message says that this interpreter is for version 3.3.2.0 of Python. It is the active state distribution, as opposed to the python.org distribution, and it was built for 32-bit Windows. Your message may differ slightly, but should contain the same types of information. If instead of running the Python interpreter interactively you want to execute a program stored in a file, then at the operating system prompt you simply append the name of the file after the Python command. $Python myscript.py. Reviewing the Python data types 3. Python comes with 2 helpful functions that assist you in exploring the language, dir, name, and help. Help, name. Dir, name, tells you all of the names available in the object identified by name. Help, name, displays information about the object called name. When you Fiverr import a new module, you will often not know what functions or classes are included. By looking at the dir listing of the module, you can see what is available. You can then use help on any of the features listed. Be sure to experiment with these functions, they are an invaluable source of information. Reviewing the Python data types. Python supports many powerful data types. Superficially, these look like their counterparts in other programming languages, but in Python they often come with superpowers. Everything in Python is an object and, therefore, has methods. This means that you can perform a host of operations on any variable. The built-in dir and help functions will reveal all. In this section you look at the standard data types and their most important operations. Note usually you can also double-click the file in your File Explorer tool, and the operating system makes the connection to Python and runs the program automatically. However, this often results in the program opening in a window, completing, and the window closing again before you can see the results, so you may prefer to type the Python filename command in full at a command line prompt. Tip: the Python reference manual, http://docs.python.org/3.3 reference/http://docs.python.org/3.3/reference/ provides the full detail should you need it. You need to be aware of some underlying concepts in Python. First, Python variables are just names. You create variable names by assigning them to objects that are instances of types. Variables do not, of themselves, have a type. It is the object to which they are bound that has a type. The name is just a label and, as such, it can be reassigned to a completely different object. Assignment is performed using equals, so assigning a value to a variable looks like this. A variable equals a value. This code binds the value a value to the variable name a variable, and, if the name does not already exist, the interpreter adds the name to the appropriate namespace. The distinction between a variable and its underlying value, an object, is thus crucial in Python. You can test variables for equality using a double equal sign, and object identity, that is, if two names refer to the same object, is compared using the as operator, as shown. Asterisk equals I love spam, another string equals I love spam. For Chapter 1 reviewing core Python. An int equals 6 int alias equals an int asterisk equals another string hashtag test equality of value true asterisk is another string hashtag test object identity false an int equals int alias hashtag same value true an int is int alias hashtag also same object identity true. Python groups types according to how you can use them. For example, all types are either categorized as mutable or immutable. If a type is immutable, it means you can't change an object of that type once it's created. You can create a new data item and assign it to the same variable, but you cannot change the original immutable value. Python also supports several collection types, sometimes referred to as sequences. Strictly speaking, collections are a subset of sequences. The distinction will be made clearer later in the chapter. Sequences share a common set of operations, although not all sequences support all of the operations. Some Python data types are callable. That means you can use the type name like a function to produce a new instance of the type. If no value is given, a default value is returned. You will see examples of this behavior in the following descriptions of the individual data types. Now that you understand the basics of working with Python data types, it's time to take a look at the different data types, including the numeric, Boolean, and none types, as well as the various collection types. Numeric types, integer and float. Python supports several numeric types including the most basic forms, integer and floating point. Python integers are unusual in that they are theoretically of infinite size. In practice, integers are limited by the size of your computer's memory. Integers support all the usual numeric operations, such as addition, subtraction, multiplication, and so on. You perform arithmetic operations using traditional infi-x notation. For example, to add two integers. 5 plus 4 9. Or result equals 12 plus 8 print, result, 20. Literal integer values are, by default, expressed in decimal. You can use other bases by prefixing the number with a 0 and the base's initial. Thus, binary is represented as 0BNNN, octal as 0ON, and hexadecimal as 0XNNN. Reviewing the Python data types 5. The type of an integer is int, and you can use it to create integers from floating point numbers or numeric string representations such as 123, like this. Int 5.0, 5 int 123, 123. Int can also convert from non-decimal bases, covering any base up to 36, not just the usual binary, octal, and hexadecimal, using a second, optional, parameter. To convert a hexadecimal, base 16, string representation to an integer, you can use int value equals int AB34, 16, 43828. Python floating point numbers are of type float. Like int, you can use float to convert string representations, like 12.34 to float, and you can also use it to convert an integer number to a float value. Unlike integers, float cannot handle strings for different bases. The float type also supports the normal arithmetic operations, as well as several rounding options. Python floats are based on the Institute of Electrical and Electronic Engineering, IEEE, standards and have the same ranges as the underlying computer architecture. They also suffer the same levels of imprecision that make comparing float values a risky option. Python provides modules for handling phi-xed precision decimal numbers, decimal, and rational fractions, to help alleviate this issue. Python also natively supports a complex, or imaginary, number type called complex. These are all typically used for fairly special purposes, so they are not covered here. The Boolean type. Python supports a Boolean type, bool, with literal values true and false. The default value of a bool is false, that is, bool yields false. Python also supports the concept of truth-like values for other types. For example, integers are considered false if their value is 0. Anything else is considered true. The same applies to float values where 0.0 is false and anything else is true. You can convert Boolean values to integers using int, in which case false is represented as 0 and true as 1. The Boolean type has most of the Boolean algebra operations you'd expect, including and, or, and. Not, but surprisingly not XOR. Note Booleans are implemented as a subclass of integer, and so also support a bunch of operations that you might not expect, such as exponentiation. You can type things like true *** false, and get a result of 1. You should basically just pretend these features don't exist and treat them as an implementation detail, otherwise, your code will become very confusing. 6 Chapter 1 Reviewing Core Python. In addition to the Boolean type, Python also supports bitwise Boolean operations on integers. That is to say that Python treats each corresponding pair of bits within two integers as Boolean values in their own right, and applies the corresponding operation to each pair of bits. These operations include bitwise and or, not, and, this time, XOR, as well as bit shift operators for moving bit patterns left or right. You look more closely at these bitwise operations later in the chapter. The none type. The none type represents a null object. There is only one none object in the Python environment, and all references to none use that same single instance. This means that equality tests with none are usually replaced by an identity test, like so. A variable is none. Rather than a variable equals none. None is the default return value of a Python function. It is also often used as a place marker, or flag, for default parameters in functions. None is not callable and so cannot be used as a conversion function to convert other types to none. None is considered to have a Boolean value of false. Collection types. As already mentioned, Python has several types representing different kinds of collections or sequences. These are strings, bytes, tuples, lists, dictionaries, and sets. You will see the similarities and differences in each as they are discussed in the following sections. A standard library module called collections provides several other more specialized collection types. You will see occasional references to these in the sections that follow. Note in many of the following discussions, you will see references to operations accepting a collection type. Usually this includes what Python calls iterables, which are objects that conform to Python's iteration protocol. In simple terms, iterables are objects that you can use in loop constructs. In most cases you will not need to worry about them, but they are described in the Python documentation if you are interested in reading the technical details. A good place to start is https://wiki.python.org/moin/iterators/wiki.python.org/moin/iterator. Several common features apply to all collections, and rather than bore you by repeating them for each type, they are covered here. You can get the length of any collection in Python by using the built-in len function. It takes a collection object argument and returns the number of elements. You can access the individual elements of a collection using indexing. You do this by providing an index number, or a valid key value for dictionaries, inside square brackets. Collection indices start. Reviewing the Python data type 7. At 0. You can also index backward from the end by using negative indices, so that the last item in the collection will have an index of -1. Whereas indexing is used to access just one particular element of a collection, you can use slicing to access multiple items in the collection. Slicing consists of a start index, an end index, and a step size, and the numbers are separated by colons. Slicing is not valid for dictionaries or sets. The step size argument enables you to, for example, select every other element. All values are optional, and the defaults are the start of the collection, the last item in the collection, and a step size of 1. The slice return consists of all selected elements from start to end 1. Here are a few examples of slicing applied to a string, entered at the Python interactive prompt. 0 1 2 3 4 5 6 7 8 9, smiley face 0 1 2 3 4 5 6 7 8 9 0 1 2 3 4 5 6 7 8 9, pet smiley 3 4 5 6 7 8 9 0 1 2 3 4 5 6 7 8 9, 3, 0 12 0 1 2 3 4 5 6 7 8 9, 3:7, 3456 0 1 2 3 4 5 6 7 8 9, 3:7:2, 35 0 1 2 3 4 5 6 7 8 9, 3, 0 3 6 9. You can sort most collections by using the sorted function. The return value is a sorted list containing the original collection elements. Optional arguments to sorted provide flexibility in how the elements are sorted and in what order. In general, empty collections are treated as false in Boolean expressions and true otherwise. Two functions, any and all, refi any the concept to allow more precise tests. The any function takes a collection as an argument and returns true if any member of the collection is true. The all function takes a collection as an argument and returns true if and only if all the members are true. Strings. Python strings are essentially collections of Unicode characters. The implications of using Unicode are discussed in Chapter 4. The default encoding is UTF-8. If you are working in English, most things will work as you expect. Once you start to use non-English characters, things get more interesting. For now you will be working in English and sticking with UTF-8. Python requires that literal strings be enclosed within quotation marks. Python is extremely flexible in this regard and accepts single quotes Joe, double quotes Joe, triple single quotes Joe, and triple double quotes Joe to delimit a string. Obviously, the start and end quotes must be of the same type, but any other quote can be contained inside the string. This is most useful for apostrophes and similar grammatical cases, he said, hi, or my brother's hat. Triple quotes of either type can span multiple lines. Here are a few examples. Using single quotes, using single quotes, using double quotes. 8 Chapter 1 Reviewing Core Python. Using double quotes print, triple single quotes spanning multiple lines, triple single quotes spanning multiple lines. A literal string at the start of a module, class, or function that is not assigned to a variable is treated as documentation and displayed as part of the built-in help output for that object. Special characters such as tabs, \t, or new lines, \n, must be prefix or quoted with a backslash character, and literal backslashes must be quoted so they look like double backslashes. You can avoid this by preceding the entire string with the letter R for raw to indicate that special character processing should not be done. Non-printable characters can be included in a string using a backslash followed by their hex code. For example, the escape character is \x1a. Note that there is no leading 0 as is used for hexadecimal integer literals. Strings are immutable in that you cannot directly modify or add to a string once it is formed. You can, however, create a new string based on an existing one, and that is how many of the Python string operations work. Python supports a wide range of operations on strings, and these are mostly implemented as methods of the string class. Some of the most common operations are listed in Table 1-1. Several other string operations are available, but those listed in Table 1-1 are the ones you will use most often. Empty strings are treated as false in Boolean expressions. All other strings are treated as true. Bytes and byte arrays. Python supports two byte-oriented data types. A byte is an 8-bit value, equivalent to an integer from 0 to 255, and represents the raw bit pattern stored by the computer or transmitted over a network. They are very similar to strings in use and support many of the same methods. The type names are spelled as byte and byte array respectively. Literal byte strings are represented in quotes preceded by the letter B. Byte strings are immutable. Byte arrays are similar, but they are mutable. In practice, you will rarely use byte strings or byte arrays unless handling binary data from a file or network. One issue that can catch you by surprise is that if you access an individual element using indexing, the returned value is an integer. This means that comparing a single character byte string with an indexed string value results in a false response, which is different from what would happen using strings in the same way. Here is an example. S equals B alphabet soup C equals BAS, 0, equals C false S, 0, equals C, 0, true. As you can see, the key is to use indexing on both sides of the comparison. Reviewing the Python data types 9. Table 1-1, string operations. Operation description. Plus concatenation. This is a somewhat inefficient scient operation, and you can usually avoid it by using join instead. Asterisk multiplication. This produces multiple copies of the string concatenated together. Upper, lower, capitalize these change the case of a string. Center, will just these justify the string as needed within a given character width, padding as needed with the specify ed phi character, defaulting to a space. Starts with, ends with these test a substring matching the start or end of a line. Optional parameters control the actual subsection of the string that is tested so the names are slightly misleading. They can also test multiple substrings at once if they are passed as a tuple. Find index, find these return the lowest index where the given substring is found. Find returns 1 on failure whereas index raises a value error exception. Refine starts at the right-hand side and, therefore, returns the highest index where the substring is found. Isalpha, istigit, isalnum, and so on. These test the string content. Several test types exist, the most commonly used being those listed, for alphabetic, numeric, and alphanumeric characters respectively. Join this joins a list of strings using the active string as the separator. It is common to build a string using either a single space or no space as the separator. This is faster and more memory efficient than using string concatenation. Split lines, partition. These split a string into a list of substrings based on a given separator. The default is whitespace. Note that the separators are removed in the process. Split lines returns a list of lines, effectively splitting using the new line character. Partition splits a string based on the given separator, but only up to the phi_rst occurrence. It then returns the phi_rst string, the separator, and the remaining string. Strip will restrip these strip whitespace, the default, or the specify ed characters from the ends of the string. Will strips only the left side, restrip strips only the right. None of them remove whitespace from the middle of a string, they only remove outer characters. To globally remove characters, use the replace operation. Replace this performs string replacement. By specifying an empty string as the replacement, it can be used to effectively delete characters. Format this replaces the older C printf style string formatting used in Python version 2. Printf style is still available in version 3, but is deprecated in favor of format. String formatting is explained in detail in the Python documentation. The basic concept is that pairs of braces embedded in the string form placeholders for data passed as arguments to format. The braces can contain optional style information, such as padding characters. You can find examples throughout this book. 10 Chapter 1 Reviewing Core Python. You can use the struct module to convert binary data from the bytes representation to normal Python types. Of course, to use this you will still have to know what types the byte patterns represent in the phi_rst place. Empty byte strings are treated as false in Boolean expressions. All other byte strings are treated as true. Tuples. Tuples are collections of arbitrary objects. The fact that they are collected together suggests that there is probably a logical connection between them, but the language puts no restriction on the objects contained. Tuples are often described as being the Python equivalent to records, or structs, in other languages. Literal tuples consist of a series of values, or variables, separated by commas. Often, to prevent syntax ambiguity, the tuple as a whole will be contained in parentheses, but this is not a requirement of the tuple itself. Tuples are immutable, so you cannot modify or extend the tuple once it is created. You can create a new tuple based on an existing one in the same way you did for strings, and you can create a new empty tuple using the tuple type function. You can use a tuple as a key in a dictionary because they are immutable. One feature of Python tuples that is very useful is known as unpacking. This enables you to extract the values of a tuple into discrete variables. You most often see this when a function returns a tuple of values, and you want to store the individual values in separate variables. An example is shown here using the divmod function, which returns the quotient and remainder of an integer division as a tuple. Print divmod 12 7 1 5 q r equals divmod 12 7 print q 1 print r 5. Notice how q and r can be treated as new, single-valued variables. A name tuple class in the collections module allows elements to be indexed by name rather than position. This combines some of the advantages of a dictionary with the compactness and immutability of a tuple. Empty tuples are treated as false in Boolean expressions. All other tuples are treated as true. Lists. Lists in Python are highly flexible and powerful data structures. They can be used to mimic the behavior of many classic data structures and to form the basis of others in the form of custom classes. They are dynamic and, like tuples, can hold any kind of object, but, unlike tuples, they are mutable, so you can modify their contents. You can also use tuple-style unpacking to assign list items to discrete variables. Reviewing the Python data types 11. A literal list is expressed as a comma-separated sequence of objects enclosed in square brackets. You can create an empty list either by specifying a pair of empty square brackets or by using the default value of the list type function. Lists come with several methods for adding and removing members, and they also support some arithmetic-style operations for concatenating and copying lists in a similar fashion to strings. You can initialize a list directly by using lists of values, or you can build them programmatically using list comprehensions. The latter looks like a single line for loop inside list brackets. Here is an example that builds a list of the even squares from 1 to 10, n*n for n in range 1, 11, if not n*n%2, 4, 16, 36, 64, 100. Table 1-2 lists some of the most common list operations. Empty lists are treated as false in Boolean expressions. All other lists are treated as true. Table 1-2, list operations. Operation description plus this concatenates two lists. Asterisk this creates a list of multiple copies of the phi_rst list. Note that the copies all refer to the same object, which often results in surprising side effects when an object is modify addition often, list slicing or list comprehension is a better option. Append this adds an element to the end of an existing list. The new element could itself be a list. The operation is effective in place and none is returned. Extend this adds the contents of a list to the end of another list, effectively joining the two lists. The original list is modify add in place. None is returned. Pop this removes an item from the end of a list or at the specify add index if one is provided. Returns the item. Index this returns the index of the Fiverr occurrence of an item in a list. Raise a value error if not found. The string operation of the same name has similar behavior. Count this returns a count of the specify add item in the list. Insert this inserts an element before the specify add index. If the index is too large, it is appended to the end of the list. Remove this removes the Fiverr occurrence of the specify add item. It raises a value error if the item does not exist. Reverse this reverses the elements of the list in place. Sort this sorts the elements of the list in place. Optional parameters provide flexibility in how the sort is performed. To get a sorted copy of the list without modifying the original, use the sorted function. 12 Chapter 1 Reviewing Core Python. Dictionaries. Dictionaries are super powerful data structures that beginners frequently overlook. They offer solutions to lots of common programming problems. A dictionary is used like a list, but its elements are accessed by using a key-value mechanism rather than a numeric index. The elements of a Python dictionary are thus a non-ordered sequence of key-value pairs. The key can be any immutable value, including a tuple. Keys must be unique. The value can be any kind of Python object, including another dictionary, a list, or anything else that Python recognizes as an object. Dictionaries are highly optimized, so lookup times are very fast. In fact, Python makes extensive use of dictionaries internally to implement namespaces and classes, among other things. Dictionaries also provide a solution anywhere that dynamically named values need to be stored and accessed. Dictionaries are also efficient where the keys are not sequential because Python uses a hashing algorithm to map the keys into a sparse array structure. If you didn't understand that last sentence, don't worry, you are not alone, and you don't really need to know. What it means for you is that Python dictionaries are fast, and they use memory efficiently. Dictionary literals are composed of comma-separated key-value pairs. The keys and their values are separated by colons, and the whole is contained in a pair of curly braces or. It looks like this. Aki evalu 2:7 booleans false 0 true 1 aki evalu 2 7 booleans false 0 true 1. You access the stored values by indexing the dictionary using the key rather than a numeric index. If the preceding example were stored in a variable called d, you could access the a key and the true values like this. D, a key, evalu d, booleans, true, 1. You can create an empty dictionary by using an empty pair of braces, or by using the default value of the dict type function. Dictionaries come with some extra operations for extracting lists of keys and values, and handling default values. Some of these are described in Table 1 to 3. Dictionaries are, by the nature of their implementation, unsorted. Indeed, the order may change when new data is inserted. The collections module contains an ordered dict class that maintains the order of insertion should that be required. The sorted function returns a sorted list of keys if the keys are comparable. If the keys are incompatible, as in the preceding example, sorted raises a type error. The collections module also provides a default dict class that enables you to specify a default value that is returned anytime a non-existent key is used. In addition to returning the default value, it also creates a new element for the given key with the default value. This is similar to the setDefault method described earlier. This can be a mixed blessing because it can result in bogus entries for badly spelled keys. Reviewing the Python data types 13. Empty dictionaries are treated as false in Boolean expressions. All other dictionaries are treated as true. Sets. Sets embody a mathematical concept that is frequently used in programming where a unique group of elements is required. In Python, sets are a lot like dictionaries with keys but no corresponding values. Sets have the Python type set. The same basic rules apply as for dictionary keys in that set values must be immutable and unique, indeed that's what makes it a set. The default value from set is the empty set, and this is the only way to express an empty set because is already used for an empty dictionary. The set function accepts any kind of collection as its argument and converts it to a set, dictionary values will be lost. There is another type of set in Python, called frozen set, that is immutable and is basically a read-only set. Its constructor works like set, but it supports only a subset of the operations. You can use a frozen set as an element of a regular set because frozen set is immutable. Set literals are expressed with curly braces surrounding elements separated by commas. Miss it equals 1, 2, 3, 4, 5. Sets do not support indexing or slicing and, like dictionaries, they do not have any inherent order. The sorted function returns an ordered list of values. Sets have a bunch of math-style set operations that are distinct from other collections. Table 1 to 4 shows those operations that are common to both the set and frozen set types. Table 1 to 3, dictionary operations. Operation description. Keys, values, items. These methods return list-like objects, called dictionary views, containing the keys, values, and key value tuples respectively. These views are dynamic, so any changes to the dictionary, deletions and so on, after they are created are reflected in the view. Get. Pop. These methods take a key and an optional default value. Get returns the value for a key from the dictionary if the key exists, or a specified default if the key does not exist. Pop works the same way, but also removes the item from the dictionary if it exists. Get has a default value of none, but pop raises a key error if no default is given. Set default. This operation acts like get, but also creates a new key value pair in the dictionary using the given key and the default value if the key does not exist. From keys. This operation initializes a dictionary using a sequence to provide the keys and a given default value, or none if no value is given. Usually called directly as dict.fromKeys, rather than on an existing dictionary. 14 Chapter 1 Reviewing Core Python. Table 1 to 4, set operations. Operation description. In this tests whether a single element exists in the set. Note, if the tested item is itself a set, S1, the result will be true only if S1, as a set, is an element of the target set. This is different from the subset, test. Isubset equals, these test whether one set is a subset of the target, that is, whether all members of the tested set are also members of the target. If the sets are identical, the test will return true in the phi-rst2 cases, but false for the operator. A superset equals, these test whether one set is a superset of the other, that is, whether all the members of the target set are members of the source. If they are equal, the phi-rst2 operations return true, the last operation will return false. Union, these return the union of two or more sets. The union method takes a comma-separated list of sets as arguments, while the pipe operator is used in phi xcd between the sets. Intersection, and these return the intersection set of two or more sets. Usage is similar to union. Difference, these return the members of the source set that are not members of the target set. Symmetric _ difference, caret returns the elements of both sets that are not in the intersection. The method works only for two sets, but the caret operator can be applied to multiple sets in infi-x style. Note that the method variations in Table 1-4 will accept any collection type as an argument, whereas the infi-x operations will work only with sets. Table 1-5 looks at the modifier operations that are applicable only to sets. These cannot be used on a frozen set, although a frozen set can be used as an argument for several of them. Note that these operations adjust the source set itself. They do not return a set, they return the Python default value of none. The infi-x operations work only on two sets, unlike those in Table 1-4, and work only on actual sets, not other collection types. You can use the methods on multiple sets, and other collection types are converted to a set where needed. Empty sets are treated as false in Boolean expressions. All other sets are treated as true. In the next section, you will use the data types in code as you explore the different control structures that Python offers. Using Python control structures 15. Using Python control structures. In this section you phi-rst look at the overall structure of a Python program and then consider each of the basic structures, sequence, selection, and iteration. Finally, you look at how Python handles errors, review context managers, and investigate how to exchange data with the outside world. Structuring your program. Python programs do not have any required, predefined net entry point, for example a main function, and are simply expressed as source code in a text file that is read and executed in order starting at the top of the file. Definitions, such as functions, are executed in the sense that the function is created and assigned to a name, but the internal code is not executed until the function is called. Python does not have any special syntax to indicate whether a source file is a program or a module, and, as you will see, a given file can be used in either role. A typical executable program file. Table 1-5, set modifier operations. Operation description. Update equals these add the elements of the target set, or sets, to the source set. Intersection _ update, and equals these remove all elements except those in the intersection of source and target sets. If more than two sets are involved, the result is the intersection of all sets involved. Difference _ update, equals these remove all elements found in the intersection of the sets. If multiple sets are provided, the items removed are in the intersection of the source with any of the other sets. Symmetric _difference _update, caret equals these return the set of values in both sets involved excepting those in the intersection. Note that this operation works only on two sets at a time. Add this adds the given element to the set. Remove this removes the specify add element from the set. If the element is not found, it raises a key error. Discard this removes the given element from the set if it is present. No key error is raised in this case if the element is not found. Pop this removes and returns an arbitrary member from the set. Raises key error if the set is empty. Clear this removes all elements from a set. 16 Chapter 1 Reviewing Core Python consists of a set of import statements to bring in any code modules needed, some function and class definitions, and some directly executable code. In practice, for a non-trivial program, most function and class definitions will exist in module files and be included in the imports. This leaves a short section of driver code to start the application. Often this code will be placed in a function, and the function will often be called main, but that is purely a nod to programming convention, not a requirement of Python. Finally, this main function needs to be called. This is often done within a special if statement at the end of the main script. It looks like this. If __name _ equals main main. When Python detects that a program file is being executed by the interpreter rather than imported as a module, it sets the special variable __name __. Note the double underscores on either side to __main __. This means that any code inside this if block is executed only when the script is run as a main program and not when the file is imported by another program. If the file is only ever expected to be used as a module, the main function may be replaced by a test function that executes a set of unit tests. Again, the actual name used is of no significance to Python. Using sequences, blocks, and comments. The most fundamental programming structure is a sequence of statements. Normally, Python statements occur on a line by themselves, so a sequence is simply a series of lines. X equals 2, Y equals 7, Z equals 9. In this case, the statements are all assignments. Other valid statements include function calls, module imports, or definitions. Definitions include functions and classes. The various control structures described in the following sections are also valid statements. Note Python does enable you to include multiple statements on a single line by separating them with a semicolon. Thus the following line of code consists of 3 statements. X equals 2, Y equals 7, Z equals 9. This style is not recommended by the Python community, using separate lines is preferred. Python is a block-structured language, and blocks of code are indicated by indentation level. The amount of indentation is quite flexible, although most Python programmers stick to using 3. Using Python control structures 17 or 4 spaces to optimize readability, Python doesn't care. Different integrated development environments, IDEs, and text editors have their own ideas about how indentation is done. If you use multiple programming tools, you may find you get indentation errors reported because the tools have used different combinations of tabs and spaces. If possible, set up your editor to use spaces instead of tabs. The exception to the indentation rule is comments. A Python comment starts with a hashtag symbol and continues to the end of the line. Python accepts comments that start anywhere on the line regardless of current indentation level, but by convention, programmers tend to retain indentation level, even for comments. Selecting an execution path. Python supports a limited set of selection options. The most basic structure is the if/elif/else construct. The elif and else parts are optional. It looks like this. If page is 9, print, it's too short, elif page is 99, print, it's too long, else, print, perfect. Notice the colon at the end of each test expression. That is Python's indicator that a new block of code is coming up. It has no start and end block markers such as, the colon is the only indication, and the block must either occur on the same line as the colon, if it's only a single line block, or as an indented block of code. Many Python programmers prefer the indented block style even for single line blocks. Also note that there can be an arbitrary number of elif tests, but only a single else clause or none at all. The other selection structure you will find in Python is the conditional expression selector. This produces one of several values depending on the given test conditions. It looks like this. A value if an expression else another value. An example might be where a screen coordinate is being incremented until a certain limit, perhaps the screen's maximum resolution, and then reset to 0. That could be written as chord equals chord plus increment if chord limit else 0. This is equivalent to the more traditional structure shown here. If chord limit chord plus equals increment else, chord equals 0. You should use caution when using conditional expressions because it is very easy to create obscure code. If in doubt, you should use the expanded if/else form. 18 Chapter 1 Reviewing Core Python. One final comment on Python's comparison expressions is worth making here. In many programming languages, if you want to test whether a value lies between two limits, you need two separate tests, like this. If a value upper limit and a value lower limit, #do something here. Python will be quite happy to process code like that, but it offers a useful shortcut in that you can combine the comparisons as shown here. If lower limit a value upper limit, #do something here. Iteration. Python offers several alternatives for iteration. The most fundamental and general is the while loop. It looks like this. While Boolean expression, a block of code else, another block. Notice the colon smiley face at the end of the while statement, which signify that a block of code follows. Also notice the indentation of the block. The block will, in principle, be executed for as long as Boolean expression remains true. However, there are two ways you can exit out of a while loop regardless of the Boolean expression value. These are the break statement, which exits the loop immediately, and a return statement if the loop is inside a function def init ion. A return statement exits the function immediately, and so will also exit any loop within the function. The else clause is optional and is rarely used in practice. It is executed anytime the Boolean expression is false, including when the loop exits normally. It will not be executed if the loop is exited by a break or return statement. One very common while loop idiom is to use true as the test condition to create an infinite loop, and then have a break test within the body of the loop. Here is an example where the loop reads user commands and processes them. If the command contains the letter Q, it exits. While true, command equals input, enter a command, rwq, if q and command.lower, break if command.lower, equals r, #process rl if command.lower, equals w, #process w else, print, invalid command, try again. There is a companion statement to break, namely continue. Whereas break exits both the block and the loop, continue exits the block for the current loop iteration only. Control then returns to the while statement and, if appropriate, a new iteration of the block will commence. Using Python control structures 19. The next signify can't looping construct in Python is the for loop, which looks like this. For item in iterable code block else, another code block. Block. The for loop takes each item in the iterable and executes the code block once per item. You can terminate the loop early using break or return as described for the while loop. You can terminate a single iteration of the loop using